Alright, so this is still 7.1, so we're still, again, kind of reviewing Chapter 6 in this first part of Chapter 7, so I'm just kind of remind you of some stuff. But we're going to add to them sort of where we're going to get to in Chapter 7. Alright, so same types of questions we had 6, we'll see again. Alright, so the first one, there's that word computers again. We'll randomly select 3 letters. So we want a sequence of 3 letters from the letters in the word computers to be used more than once each to form a sequence of 3 letters. So I'm going to pick 3 out of 9 total different letters, or if you count them, there are 9 total different letters in the word computers. No more than once each means no repeats. Sequence means order is important. Alright, so we can use a permutation if I want to. Although these examples might be easier without a permutation. You could use a permutation formula. I'm actually going to do these without the permutation formula. But the formula is just plug it into the calculator and it does the subtraction step for you. Right, the first question is, find the number in the sample space. So how many total sequences of 3, if I have 9 letters to choose from and I can't repeat them, am I capable of having? So this is looking for the number in my universal set, right? I can pick any 3 of my letters. No repeats no repeats and order matters, and so I can have 3 picks. I can pick any of the letters in the word computer. So the first pick had 9, but I picked 1, so there's only 8 left over for the second pick, and only 7 left over for the third pick. And so the number in my sample space is 9 times 8 times 7, so there's exactly 504 total sequences of 3, right? 3 letters picked from the 9 letters in the word computers. Right, find the number of elements in the subset B, where set B is the number of sequences that contain exactly 1 vowel. So now I'm looking for a subset, an event, right? Subset. So number in my subset B. Right, I want to pick exactly 1 vowel. So I'm going to pick 1 vowel. I start with what I want. Pick 1 vowel. And then it didn't say when I picked it. Did I pick it in the first one, the second one, or the third one? So then I place the vowel in the sequence. Alright, and then I still have 2 more spots left to fill. So I still need 2 others to fill out the 2 places that are left. Alright, well I picked 1 vowel. Well, if I go in the word computer, there are 3 choices. So I have 3 choices for my letter, my vowel. 3 choices. So I pick a vowel, there are 3 options. I have 3 choices for those. And we multiply. That vowel could show up in the first spot, the second spot, or the third spot. So there are 3 places my vowel could show up. And then I still need to finish. Once I've picked the vowel and placed it in the first, second, or third spot, I still have to finish it off with 2 others. And other meaning other than a vowel. These are non-vowels. And so there are 6 that are not vowels. So 6 for the first spot. And then I only have 5 left over for the second spot. And so the number of outcomes where I'm picking a sequence of 3 and I get exactly 1 vowel is 3 times 3 times 6 times 5. And when you multiply that out, it comes out to 270 sequences with only 1 vowel. Right, so none of that was new. That's all stuff that we learned in Chapter 6. The new question that we're going to be answering in Chapter 7 is, so the next question, what's the likelihood, if I do this experiment, what's the likelihood subset B will happen out of all possible outcomes? So, out of all my outcomes, there are 270 ways for B to happen. Out of 504 total. Alright, so the odds of it happening, the probability of it happening is 270 out of 504. And that's what we're going to get into in Chapter 7. That's the next question we're going to answer in Chapter 7. Alright, so a second experiment that we're going to look at, again, is one that will, bag of marbles, bag of candy, you're going to be familiar with again. So if you didn't get those in Chapter 6, make sure you go back and look at them, because you're going to be doing them again here in Chapter 7. Alright, so I've got my bag that contains so many blues, reds, greens, and yellows. I pick a handful of 3. So I'm picking a handful, so that means combinations. Alright, as soon as I see handful, I'm going to pick 3 out of 5, 9, 13. Alright, so find the number in my sample space. So number in my sample space, I pick any 3. So it's combination out of 13. I can pick any of the 13. So I pick 3 of the 13 for my handful. So again, combination, you have to use the combinations key on the calculator. So 13 combinations, choose 3. So the number of total handfuls are 286 handfuls total. Alright, nothing new. Now the subset. Is that term at least? I want at least. So number of elements in subset A. Subset A is the number of handfuls with at least 1 blue marble. Alright, so I want to find number of handfuls with at least 1 blue. Remember, at least 1 blue means 1 blue or more. So I could get 1 blue, 2 blues, or 3, and you could solve it that way if you want to. I'm actually going to use the complement because it's easier, so I'm going to use the complement number in my universal, which I have, minus number of cases I don't want. Well, I want at least 1 blue, so the complement of getting at least 1 blue is no blues. Alright, well, I already know what my universal is. That's 286. So I just have to figure out, well, how many ways are there to get no blues? Well, that means I'm just picking out of the marbles that are not blue. Well, there are 8 non-blues, and I want 3 of them, right? Because I always have to finish my handful. So combination out of 8, choose 3, and I plug that into the calculator. So 286 minus all of the handfuls with no blues. Combination 8, choose 3 comes out at 56. So there are 56 handfuls with no blue. I take my total, 286, minus my 56, and so that leaves me with 230 in event A. Alright, so 230 handfuls with at least 1 blue marble. So then the next question we're going to get to answering in this chapter is, well, what's the likelihood subset A will happen? Well, the likelihood would be there are 230 handfuls out of 286 that have at least 1 blue. Meaning that's what's our odds. So it's pretty good odds. Most of our handfuls, alright, 230 out of 286. Alright, so again, that's what we're sort of foreshadowing that we're going to get to. That's why you have to know how to count stuff in Chapter 7, because you're going to have to count 2 sets. You're going to have to count the subset we're looking at and the universal set. You actually have to know both, the subset and the universal set. So you have to get a little quicker at counting in Chapter 7. Alright, there is one more video that we're going to go over in 7.1. It's specifically looking at tables. We'll get to that in the next video.